All right, let's dive right in. Today, we're going to pull back the curtain on one of the most powerful and popular algorithms in all of machine learning, K-means clustering. We're going to see exactly how it finds those hidden, meaningful groups in all sorts of data. So, let's get to it. You ever wonder how a streaming service just knows what movies you'll like? Or how a business can send you an ad that feels like it was made just for you? It all starts with a really simple but powerful idea. How do you find real groups in a massive sea of data? Well, the secret is that these systems are incredibly good at finding hidden patterns. And the best part? They don't need someone to label the data for them beforehand. Instead, they use something called unsupervised machine learning to just discover the natural groupings that are already there. Now, this whole process has a name. It's called clustering. The main idea is actually pretty straightforward. You want to group things together so that everything inside a group is super similar, but the groups themselves are as different from each other as possible. So what does a good set of clusters even look like? Well, the goal here is to take what looks like a total mess of data points and find some real meaningful structure in it. It's about creating order from chaos. And really, it all boils down to two key things. First, you want the points inside any one cluster to be packed together as tightly as possible. Think, compact and dense. At the same time, you want those different clusters to be as far away from each other as they can be, making them really distinct and separate. So how do we actually do that? Well, one of the most famous methods is an algorithm that I like to call the K-means dance. It's a really intuitive, step-by-step process for finding these groups. Okay, so officially K-means is an algorithm where you, and this is a key point, you decide ahead of time how many clusters you're looking for. That number is the K. The algorithm's job is then to go and find the best possible center point, which we call a centroid, for each of those K groups. And here are the steps to the dance. It's pretty simple. First, you pick your K, and you just drop that many centroids randomly onto your data. Second, every single data point gets assigned to whichever centroid it's closest to. Third, you move each centroid to the average spot of all the points in its new group. And finally, you just do steps 2 and 3 over and over again until things stop changing. Let's actually watch this happen. So imagine this is our data. We've decided we want to find 3 groups, so our K is 3. The algorithm starts by just plunking 3 centroids down in completely random places. And now for step 2, the assignment. Every single little data point measures how far it is from each of the 3 centroids, and it joins the team of the one it's closest to. And bam, just like that, you can see they're now colored based on which cluster they belong to. Okay, next up is the update. Those centroids that started out in random spots, now they get to move. Each one repositions itself to the true center, the average location of all the points that were just assigned to it. You can see them snap right into the middle of their new color groups. But wait, the dance isn't over. Now that the centroids have moved, we do it all again. All the points look around again and get reassigned to their new closest centroid. See how some of them might switch teams? And then the centroids update their positions again, getting a little closer to their perfect spot. We keep this assign and update dance going until finally we get to a round where not a single data point changes its cluster and the centroids don't move at all. We call this convergence. The algorithm has found stable groups, and the dance is finally over. So it's really important to get the trade-offs here. On the one hand, K-means is super popular. Why? Because it's simple to get, it's really fast, and it can handle huge data sets. But it's not perfect. You have to tell it how many clusters you want, the results can sometimes depend on where those first random centroids landed, and it can get thrown off by outliers. And that last point brings us to what is probably the single biggest question you have to answer when you use K-means. How in the world do you pick the right number for K? I mean, seriously, the quality of your results completely depends on picking a K that actually matches the real structure in your data. Are there 2 groups? Is it 5? Maybe it's 20. How are you supposed to know? Well, thankfully, there's a popular trick for this called the elbow method. The idea is pretty smart. You just run the K-means algorithm a bunch of times with different values for K. You might try K equals 1, then 2, then 3, all the way up to, say, 10. And each time, you measure how tight and compact the final clusters are. Then you plot those results on a graph. And what you're looking for is a bend in the line that looks kind of like an elbow. You see, the graph will usually drop really fast at the beginning and then start to flatten out. That elbow point is your sweet spot. It's the point where adding more clusters doesn't really give you much benefit anymore. Okay, so now that we've got a handle on how K-means works, let's talk about where you actually see it. This is where the theory really hits the road and has a huge impact. And honestly, it's pretty much everywhere. When a business wants to find different groups of customers for marketing, that's K-means. When you want to automatically sort thousands of news articles by topic, K-means again. It's even used for things like image compression and for flagging weird behavior, like potential fraud and insurance claims. It's a real workhorse. And this quote right here just perfectly sums it all up. Doesn't matter how complicated the problem is, the basic goal is always the same. Make groups that are tight on the inside and separate on the outside. It's such a simple concept, but with incredibly powerful results. And that kind of leaves us with one last thought. With a tool like K-means, we now have this amazing ability to find structure where it just looks like chaos. So the next time you're looking at a complex world full of data, you can ask yourself, what hidden patterns are just sitting there waiting for someone to find them?